Hello, everybody. So yeah, I'm gonna continue working on my game here. I have a skybox, kinda. I mean, it's a box. You can tell it's a box, and that's the problem. You can tell it's a box, so it's not supposed to look like you're inside of a box. So that's my goal. Well, I don't know if I'm gonna get there today, but I want to try to continue with the Perlin noise and make it look like there's clouds at least. I'm gonna try just for one side. And then once I get the Perlin noise working and it looks like clouds, then I'll try to blend it all around the actual sky map. So I don't know if I will succeed. Last time I miserably failed, but it's a new day, so let's see how well I can get this. So where did I leave off? Okay, so I had this function, poorly named function, then I had these cubic interpolation functions, and then I had everything flattened out. Okay, so I think what I'm going to do starting off, I'm going to go back and change this to be a an actual array, not a pointer. Oops. All right, so this is 0, 1, 2, 3. And see. So yeah, this would be a 4 by 4. I don't need that. And that's going to be ij. Actually, yeah, so let's put it back to where it was, but I think I'm going to do this differently. I think I'm going to make a different function. I'm going to say static void. I'm going to say, how do I say this? Create cubically, I don't know if that's spelled right, interpolated plane. I don't know, it's a dumb name again, but it's going to take all of the stuff here, except for, I don't want to really initialize these. And it's also going to take in a frequency. So like how much, I'll just call it freq. So how much you're interpolating between each resolution. I don't know. So this is going to set up the thing based on the frequency. So what I want to do is I want to know how much to divide the width and height by, and that's pretty much what the frequency is all about. So I'm going to do this. I'm going to say U32, coming up with names of the, I don't know, division width is the width divided by the frequency, and then the same for the height. So division height equals height divided by the frequency. Okay, so then once I have that, well, let me calculate the size of the whole texture. So that's total size. Yeah, total size is the width times the height times 4, because there's 4 components to each pixel, and this is supposed to be freak, not freg. And yeah, so I need a bunch of random numbers, and the amount of random numbers I need depends on the frequency, and it's basically 4 for every frequency. So let me see, random amount is frequency times 4, and then once I have that, I need to make my seeds. So okay, I'm just gonna dynamically allocate things, because this isn't performant code. This is just going to run one time during development. Like I said, once I get it working, I'm going to bake it to a file and then not have to worry about it. So I don't care if this is fast. I'm just going to dynamically allocate my randoms. I'll call this randoms. So that's F32 double pointer malloc. So I need the size of whatever a float pointer is. Times total, no, times, oh yeah, times the random amount. Okay, so then I need to iterate through that. Is less than randoms. No, random amount. There we go. And then randoms at I needs to be allocated to a new float pointer. Size of a float times that. So that's going to make a square matrix of random, well, just it's right now it's just making the square matrix. And before I forget, let me go ahead and free all this stuff up. It's less than our amount plus. So then we need to free randoms at I, and then once all that's done, we need to free randoms. All right, does that all compile? Yeah. Okay, so then I need to actually initialize these with random numbers. So for U32 I is 0, I is less than random amount, I plus plus, and another one, J is 0, J is also less than random amount, J plus plus. And then so the randoms at J is equal to random U32 divided by max U32. It's supposed to be a float from 0 to 1. And I probably need to cast these, don't I? Okay, so that's going to set up my matrix of random numbers. And so with that, I can now cubically interpolate. But I'm going to have to peel apart because I'm only using 16 at a time, right? Because this is 4 by 4. So I'm going to have to peel apart when the frequency is higher than 1, the 16 that I need, but I'll figure that out in a second. And you know, I think I'm going to make this take in a float pointer and then just have it from 0 to 1. And then multiply it by 255 later to get the pixel color. Okay, so so now I need to iterate through all of the pixels. Less than height, I plus plus, equal to J is 0, J is less than width. And then yeah, so I need to know what row and column. Basically, I need to figure out what index to pull this out of. So let me think about this. If I say row, it's I divided by the division height. So that's what row I'm in. And then the column is J divided by the division width. So then using that, I can then peel apart the 16 random numbers I need from there to seed my bicubic interpolation, right? So let me think about this. Okay, so I'm going to make a new float. I'll call this RC. I don't know. It's not really a seed. It's a. I'll just call it rnum. All right, so this is going to be a 4 by 4 thing, and it's going to have 4 by 4. So basically, I'm going to take the random numbers here. So I need randoms, row, and column. And so that's going to be all of these, but then the column is going to increase. Wait, 0, 1, 2, yeah. So that's supposed to be 2. Okay, so with all of that, oh, so then these should change here. So that's +1, +2, and +3. So let me go ahead and you know what I'm going to do? I'm going to go ahead and do +0 for all of these, just so it lines up. Making my code slower just to satisfy my OCD. Okay, so that is the 4x4. So then I can just, I believe, just call bicubic interpolate with rnum as the values. Oh, but I need to calculate the x and y, don't I? Let me come back to that in a second. So it's going to be a float. Yeah, so float for the x is, so this is where I got stuck last time, right? Well, one of the many places I got stuck last time. So it's got to go from 0 to 1, but then it's got to reset once it passes this amount here. So that's wait, so x modulo the division height, no, not x, I modulo the division height, and then, wait, so that should be a float. And then I just want to divide that by the division height, I think. This doesn't seem right. Wait, hold on. So I modulo subdivision 0 divided by 0. Oh yeah, because you want to be doing it. Yeah, I think that's right. Well, I guess I'll find out. X and Y. Oh wait, what am I doing? Wait, randoms. Oh, that's supposed to be I and J. There it goes. Okay. Okay, so now that is going to, so I don't really need this anymore. And so what I'm going to do is I'm going to, let me also calculate the total size here. Okay, so in fact I can probably, well, let me keep that just in case I need it. Oh yeah, also need to put this into the buffer here. So actually I don't even need to do that. I can just say buffer, I need a counter. Oh wait, I forget. No, sorry. I didn't undo all this. Okay, so I do need that because it's 4 bytes per pixel, or yeah, per pixel. So then buffer at counter plus plus, oh, geez, it's equal to V. So I only want the red and green components to be affected by V because I want it to look like clouds. So I want the blue to be maximum, and then of course no transparency. So with that, okay, so that should build up the buffer here. So I'm gonna just allocate some memory to do this. Yeah, because I need to add everything up and then put it into this buffer here. So let me do this. Let me make a float 32 pointer. I'll call this tbuff. Malloc. So we want total size times whatever a float is, and then let me make sure I free that up. And what else? Okay, so I think that's it. I think I can use this to now do this. So let me see. So if I say, what did I call it? Create cubically interpolated plane. Yeah, so I just want to put in tbuff and then the width, the height, and then for now I just want a frequency of 1 just to see if that works. Okay, so yeah, it's compiling and it's not showing anything because I now need to copy tbuff over into the buffer. So for u32i is 0, I is less than total size. And then so buffer at I is equal to tbuff at I. And then tbuff's from 0 to 1, but I want this to be from 0 to 255, so I just multiply that. And then that should give me back what I had before, hopefully. No, not at all. Oh yes, because this should be 1. Okay. Yeah, so that's what I had, and it's only one face because I gotta actually do this 6 times. But yeah, so I'm just trying to get one side working, which I guess will now be the right side. Yeah, so I can probably get rid of this now. Okay, so then if I increase the frequency, it should look more interpolated, which kinda. Let me crank it up to 16, that'll really be able to tell. Oh yeah, there we go. I mean, that's not at all what I want, but yeah, on the right track. So I'm already getting further than I did last time, which is good. So now that I think about it, I might need 2 of these because I want to add everything, sum it all up, and then divide it all by 4. So I don't immediately think of a better way to do this. Let me go ahead and just take up more memory. Tbuff 2, why not? Okay, so I'm going to use tbuff 2 as like the temporary thing, and then so what I want to do is actually I could just copy all this. And tbuff at I is equal to tbuff 2 at I. Okay, so then I want to do this a bunch more times. So with a frequency of 2, and then after the first one I want to add it. All right, and then 4, 8, and plus equals, yeah. So then once I do all that, I want to divide everything by 4. And then that should give me what I want. There we go. Looks pretty cloud-like. Not perfect, but good enough for now. All right, so let me, okay, so this is gonna line up, but I'm gonna just try this. So U32, counter 0. And then Okay, cool. So I got clouds all over the place, but they're not lining up, so you can very definitively see the corners of the box, which is not ideal. So I think that's my next step, is to somehow figure out how to get them to line up. And it's not hard in theory, but in practice it's going to be tricky, because I think what I need to do is make sure that on each seam that the random numbers I generate are the same, so not random. And that's going to be tricky. Let me think about this. So if I have a texture, so I'm sure everybody's probably seen this, where you have, put it in a better spot. Okay, so this is my negative x. Let me make this bigger. Negative x. And so that would make this positive x. This is negative z. This would be positive y, negative y, and this would be positive z. So I want this seam here to match up with this seam here, this seam here to match up with this one over here, this one to that one to this one, that one to this one. This is tricky. So well, I was thinking I could just create a huge texture, right? That's 3 times taller and 4 times wider than I would need for just one. And then copy everything to the buffer. That would make these all line up. And then I could probably easily get these to line up with that, and then this to that. But then getting this to line up with that, and this to that, that's going to be the problem. So I think I need to figure out a way to, when I generate my pseudo-random number, I need to make sure I'm getting the same number based on the position. Can't play the game. Okay. I don't know, I somehow have to retain the randomness for each one of these. I'm not coming up with any quick solutions off the top of my head. I don't know. Let me see. This is like kind of done, but I still want to make it nicer. Oh yeah, I fixed that. Make text in canvas positioning scale with window. Yeah, I still have to do that. I don't know, I'm getting sleepy. I think I'm gonna call it, and then I'll get this working next time, and then I will move on to something different. Probably terrain or something, maybe shadows, I don't know. But yeah, I'm gonna go ahead and save this and more skybox. Actually, I'm gonna say Perlin noise progress. All right, that's it. Short stream, but it's fine. See you next time.